Hello everyone, I'm Ishani Mody, and today I'm going to be talking about my machine learning project, Global Migration Analysis. To give a little bit introduction about the topic, migration throughout the human history has played a fundamental role in shaping economies, the way cultures meet, and people across different communities live. People have been crossing borders for various reasons like economic opportunities or political instability, family reunion, etc. But in the modern times, the migration patterns have changed because of globalization, conflicts, and climate change. In 2020, the United Nations um, estimated that there are more than 280 million international migrants across different countries, and this figure has kept growing since the past few decades. Because of this large scale movement of people crossing borders, creates opportunities and challenges for different nations. While a lot of extensive research has been done by International Organization for Migration and World Bank, where they conducted in the examination for migration statistics and highlighting the key trends, but but while these reports offer valuable insights, they often focus only on the broader regional trends or specific migration crises. This leaves gaps in understanding at a lot more granular levels, and that's what this project seeks here. The idea of this project is to combine migration data with factors like population growth, employment trends, and urbanization patterns. Um, so to I actually I actually found data through three different sources. The first one being international migrant stock data. This data gives information about the number of people who migrated each year from 1990 to 2020 at 5 year intervals. It is divided into three more parts. The first one is the total number of people who migrated. Second one is broken down into different age groups of people who migrated, and third one being um, the division based on their genders and the age group. Second one is US Census Bureau World Population Data. So this data has been fetched using IDB API, which has demographic measures of 200 countries with population more than 5,000. In this, each country and area has data of total population, population by age and sex, demographic characteristics like fertility, mortality, and migration. The third one is ISO country list. This is a combination of two data sets. First one from ISO 3166 article, which has alphanumeric country codes, and second one being UNM49, which has standard codes by the country for their regions and subregions. Upon gathering the data from these three sources, I did the standard procedure of cleaning and pre-processing and then merging it. And this is a snippet of what the final data set looks like. Talking about the goals of this research and who benefits from these, the first one I think is government and policy makers. Migration analysis helps them understand migration trends and creating regulations that balance the need of their economies, but also keeping humanitarian and social considerations. Second one is international organizations. They rely on migration analysis to get idea about refugee crisis, to replan settlements, and ensure that migrant rights are upheld. Third one is NGOs. So NGOs use migration analysis to know like what supports migrant would need, maybe like medical assistance, food assistance, legal assistance, and they also advocate for migrants and their rights, and also address their issues like trafficking or discrimination, etc. The fourth and the foremost, which is business and employers, I think they are the ones who are benefited highly with the migration analysis, since it gives them an idea of availability of skilled or unskilled laborers in different regions, or if they want to expand their business in different regions or investing. Migration analysis helps them grow overall. Coming to the patterns and insights that are derived from the data set, the graph on the left are box plots, which is categorized between males and females of different age groups. The first one is so if you see males from age 20 to 64 have the highest migration, followed by females from age 20 to 64. But overall, men have a higher tendency of migrating compared to females. The second graph, which is on the right side, shows distribution of top 10 countries, and it is distributed on the age gaps. So from age 20 to 24, there is a constant rise in migration up till the age 50 to 54. Post that, there is a decline in migration, but then it suddenly spikes at age 75 plus. And age group 30, but the age group between 30 to 40 had the highest migration, with Saudi Arabia having the highest migration compared to all the other countries. In this slide, the graph on the left shows the top 10 countries which have the highest number of refugees, and the graph on the right shows the top 10 countries which have the highest foreign-born population. Coming to the machine learning concepts used in this project, the first one is principal component analysis. I implemented 2D PCA and 3D PCA, where the results were 47.28% of variance for 2D PCA and 56.49% of variance for 3D PCA. If you look at the graph on the left, we notice that the first few components capture a significant portion of the variance, and the steep keeps increasing steadily. But the curve starts flattening at point 14, and it starts diminishing post that. So in this case, basically 14 principal components are needed to maintain 95% of variance as presented in the graph. To simplify this, I could say that uh, uh, we can reduce it from 29 features to 14, and this allows it to keep the efficient data for presentation, while it also removes the redundant data, but it preserves the critical insights. Moving on to the next one, which is logistic regression. It is a supervised machine learning model where the accuracy I achieved was 92.5%, indicating that it has it predicts pretty well in determining the countries which have the highest or the lowest fertility rates. Logistic regression, the precision of 88% and a recall for 94% for low TFR meant that it correctly identified most low fertility countries, and a precision of 96% and recall of 91% for high TFR showed that it correctly predicted countries with high fertility. Overall, logistic regression model demonstrates high accuracy, but I think it also maintains the balance between precision and recall, which makes it a ideal tool for fertility classification. The third one is a naive Bayes. So there are four types of naive Bayes that I performed, namely multinomial naive Bayes, Gaussian naive Bayes, Bernoulli, and categorical. Uh, Multinomial naive Bayes had precision of 63.6%, which is kind of average, and it shows that there is like significant imbalance, and hence it's not the ideal choice for predicting. Gaussian knife Bayes, on the other hand, has the highest accuracy of 92.5%, which means it is super effective for predicting countries' fertility classification. Um, Whereas Bernoulli and categorical, both of them have the same accuracy of 86.5%. But the way these models predict is different. Bernoulli uses binary features, whereas categorical uses like ordinal data, and then it separates into discrete beans. The fourth one is decision trees. So I performed three different types of decision trees. The first one being entropy. In entropy, it is you can notice that 150 it predicted 154 low fertility countries to 20 high fertility countries correctly, and it gave 8 false positive and 19 false negative, which took its accuracy to 93.3%. Gini, on the other hand, correctly predicted 155 low fertility countries to 25 fertility countries, 7 false positive and 14 false negative, which is lower to entropy, which increased its accuracy to 94.8%. The third one is subset of features. So this is basically when you choose certain features to predict. Um, Here I chose mortality rate, death rate, and life expectancy. And the results were that it correctly predicted 138 low fertility countries, 207 fertility countries correctly, and it had the highest false positive and false negatives, which brought down its accuracy to 86%. In order to conclude, I would say that as the times keep changing, the trends will of course keep changing, and there'll be more features that will be added to the migration analysis. And I think it's important for the governments and organizations to keep a note of it to plan a better future. And mostly, I think policy makers and researchers um, tend to benefit a lot from the migration analysis because it helps them develop strategies for um, their local markets, or for researchers to come up with better globalization and economic development. But I think overall, to conclude, I would say that in today's time, migration analysis is not optional, but rather mandatory uh, for the world to become more interconnected. Thank you.